Hello. Is that loud enough, you guys? It's good? Okay. Hello, everyone. I'm Substack from the internet. Oh, hang on 1 sec. I have to refresh this. There we go. More on that later. So I am going to talk about modularity and why you should put everything on NPM. I know. So I have this tool called Browserify, and when I started that project a while ago, I think in 2010 at some point, I just wanted the browser to be nice, like Node is nice. And that means having module.exports, having require work sensibly, having different versions of things resolve properly, having it walk the dependency graph in a sane manner. Because when you can build applications that way, you have crazy superpowers to slay dragons. Because the browser really is this hostile environment where there's a lot of weird APIs going on. It's not a very pleasant place by default. I mean, it's getting better, but what if we had just magical techno-wizard powers to build crazy things? So let's do that. So here, no tricks up my sleeve. This is an empty directory. Let's make something with Browserify real fast. So the first thing we can do, just like in Node, we'll just have an empty file. And we can just, I don't know, console.log beep boop, right? And then I can run that in Node and it works, right? But that's boring, right? What if I have a second file where I do some computation and I put a module.exports equals function, and then I'll just return n plus 5. Cool. You know, I think people who have done any Node are kind of used to this way of composing applications. It's super nice. And then you just do var foo equals require /foo.js. And maybe I'll console log of foo of like 3 times something else. OK. I can run that in Node, right? And it works. So we have 888. That's great. But if I want to run this in a browser, it's not maybe obvious how to do that. But I think it's really worthwhile to compose your code this way in the browser, because it's very pleasant. Anyways, to do that with Browserify, it's really simple. You just do Browserify and the name of the start file, and then it generates this output that you can stick. You can either write it to a file, you could just run it in Node directly, and it does the same thing as doing node main.js. You can stick it in a file, right? So you can stick it in bundle.js. Then to run it, we can maybe just have an index.html, right? So script src bundle.js, right? And so we can just open that file in another tab, check that out, and bam! It's exactly the same code in the browser and in Node, and it's super nice. But it gets better because we can also include Npm modules in our code. So maybe our foo.js computation is not advanced enough, and when we want to require a module. So we could do something like, maybe we need the gamma function, which is on NPM. You can just npm install gamma. It'll install it in node modules, and then in your browser code, you can just do var gamma equals require gamma. And it works, right? So we can just return gamma of n plus maybe 0.2 or whatever. I don't know. Gamma is like the factorial function, actually, but continuous. So it works with floats. If we run that in Node, we get a different result. And we can just re-browserify our bundle and then open it again. And the same answer in the browser, just with console.log. It's really simple. And so what this kind of approach lets you do is you can actually achieve code reuse at scale. Like here, for instance, is the Browserify package itself. This is the entire dependency graph of the Browserify project. It's massive, but what's really cool is all of the pieces just do one little thing. They're very focused on one little thing. So we've got like this module, who's written by Chris Dickinson. We've got another module written by Forbes Lindsay. We have all of these contributors. Everybody is helping each other out, and we're all writing little tiny pieces that just do one thing really well. And we can really glue those together at massive scale. And once you have a good module system in place, it's just you have these crazy superpowers. It's excellent. Here's another one. The Leveldb project that Rod talked about yesterday is organized in a similar fashion. What's really crazy about this project is it works in Node and the browser, and the appropriate level was shimmed out for the browser code, and then everything else in the ecosystem can just use that natively. It's wonderful. Here's another project, the Voxel.js project. This is probably one of the biggest open examples of using Browserify at scale. And just hundreds of these modules that people have written and have contributed, and like people just come in out of nowhere and publish a module, and then everybody can benefit from that. We really are starting to see a huge commons emerge. But what's important about NPM is that, what's important about NPM as well is that you'll notice even in this really front-end heavy project, Voxel.js, there are modules that work in both places. We have like template rendering in this project. We have a bunch of modules that work in both places. So you can have streams that work in the browser. You can have all of these shared pieces. So you might have your front end and your back end, but you have this huge area in the middle where you can achieve a crazy amount of reuse. So it's really important not to have just a package manager for browser code and just a package manager for Node. You really, if you want to achieve a lot of reuse and if you want to stop duplicating effort all over the place, you really need something that is as big of a tent as possible. You need to widen the modularity tent because you can consume pieces that are common. So maybe a library only is for front end and a library is only for Node, but they probably have a number of shared dependencies that will work in either place. We shouldn't need to use a different system to manage both of them. That just adds complexity. So there's one other thing I want to show. So this very slide presentation itself has a browser in it, but it's also slides. So how did I do this, you might ask? It's quite simple. So here, inside of my own application, I will view its own source. So hey, wait a sec. This looks like Node code, right? Varfs equals requirefs, varpath equals requirepath. That's kind of weird, right? But over here, whoa, goodness, I've got document.createElement. So how does this work, you might ask? It's just a really simple Browserify app. And there are a couple of little tricks you can do. Like to make this fs.readFileSync work, I just use a Browserify transform. So when I go to build this module, I do Browserify-t brfs. And what that does is it takes that fs.readFileSync call and it turns that into a string. So when the browser views this, it just sees var src equals fs.readFileSync. Here, I can show you. Bundle.js. Var src equals, well, oh yeah, space. There it is. Right. Here is that entire file, which is a markdown file, that I'm parsing in the browser to generate the slides. And then I'm also inserting the terminals. And I'm using the marked module directly from NPM. It works completely out of the box, even though it has dependencies. You can really achieve a lot of crazy things when you go with this approach. I'm using, I talked last year about MuxDmux. There I'm using it. I've just got a stream here for my WebSockets. I've got Exterminate does the browser rendering. All of these little pieces just are based upon all of this great work that has been done in the community, completely outside of what I or my immediate friends have done. You can just pull in all of these wonderful, very focused, tiny things that really fill out the long tail of what can be done. So speaking of expanding the modularity tent a little bit, so I want to talk about how free software used to be back in the old day, back in the old country. We would have these giant projects that would be very centrally managed, and they would have 5-year plans, and they would decide things from on high about how it was going to be. But I really think that we have a much better model that's emerged lately with NPM and GitHub and very distributed tools where people make individual connections and individual relationships, and the dependencies are more like this and less like one giant package that does everything. Because first of all, it's much easier to take functionality and put it into something that already exists than to port that functionality to something completely different. Like to take a Rails app and port it to some other framework in another language would just be an absurd amount of effort. But even to take something like a big framework-heavy app, if you can use Npm modules, you can take little tiny pieces of functionality that do one thing well and put them in your application. But if you don't even you also don't even need that basis, that big framework to do things, because the community has really built out a whole lot of amazing technology, and it's just maybe a little bit tricky to find it, but it's definitely out there, and I very much advise you to go and look for it. But, so the reason why NPM works is because anarchy works. In particular, anarchy works very well for publishing, and NPM is a publishing platform. And there is a king of NPM, Isaac, but Isaac is pretty busy working on Node right now, so he's pretty hands-off about everything. It's great. There's no canonical packages. There's no kinds of, there's no central gatekeeper who you have to talk to publish a package. You npm add user once, and then you npm publish whatever you want, and you can have whatever name you want. The reason why this works is that there are, well, how many packages are there? There's like, maybe if we establish an upper limit of like 256. Okay, there are infinitely many packages available on NPM, infinitely many names you can use. There's infinitely many packages that have yet to be written. And there's such a wide diversity of solutions to our problems that this approach, I think, will scale. I mean, it does scale, right? We have packages like this that just work excellently at scale. Everything is independently versioned. You get all of the benefits. But let's talk about C. So Node itself is written in C++, but C, and C, of course, was the basics that was written for Unix. It was written alongside it, and it was written for it. And Unix was very much about, is still about, writing tiny pieces that compose well, that do exactly one thing well, and gluing them together with pipes, with simple abstractions like files and directories, very simple tools, not big tools. It might be, less efficient in some instances to write code this way, but it's vastly more productive. It's vastly easier to contribute, and it's vastly easier to take novel combinations of tools that other people have written and to use them in your own app. But C, of course, is this terrible, terrible language itself. I mean, we have, and importantly, we're going to have to rewrite a lot of C here pretty soon with the 2038 bug that is looming. Our 32-bit floats are going to run out of bits, and we're going to have to refactor a lot of things. But of course, include is really terrible, right? We don't achieve that level of node-style functionality that we're used to in the browser and in the server. We have this horrible thing that just dumps a bunch of globals into a namespace. It's very bad. But what if we had pound require? What would that look like, right? And what if we had like export equals foo, and that foo didn't leak out, it was like in a generated namespace. And very, very importantly, what if when we did pound require, we gave it a file path, and then we gave it a qualified import to put that code into. This is really important because without importing into a lexical, then you're in the same boat as pound include, where everything is just dumped into a namespace, and you have no idea reading a new piece of code where anything came from, because it's just you're modifying a state machine, and it's very messy. So I have this project called .c. .c is meant to put C packages on NPM, because why not? First of all, NPM already has a lot of C code on it by way of node extensions, and there's really no good place to put it. So why don't we just use something that already exists? That's what the A is for in whatever, with a circle around it. So what does that look like? Well, here's a new empty directory. Let's make a C module with .c. It's just a simple preprocessor for GCC. So normally in C code, right, we do pound include stdio.h or whatever, and that gives us printf, basically. But you have to know that, which is kind of crap. And then we'll int argc, and we'll make a char array. There we go. We'll return 0, like a good C program. And maybe we'll printf, just something silly, right? We'll include another library to convert the first argument to an integer, and that's in stdlib.h. Goodness, and you have to know all of this ahead of time. It's really not obvious reading this program for the first time where any of this stuff comes from. You can use this function h2i to convert to a string. There we go. That's a program. You can just compile it with GCC like that if you want, and you get an a.out, whatever, 5. But what if we want like another file to put our computation in, right? A foo.h or foo.c, like we did in the Browserify example. Well, it's okay. Maybe you can have like int foo and then take a parameter and like return n plus 5 or something. Okay, but now, if you want to pound include that file, you have to set up include paths. It's very complicated. And include paths are like kind of the pseudo-global thing, so you have to have a make file, all of the ceremony. Whatever, let's just do it like we do it in Node. Export equals foo. And in main.c, we'll just, we'll just require /foo.c as, and we can call it whatever we want. We'll call it bar. That's cool. And then we'll bar of that argument, so now it'll do something fun. And then to compile it, instead of using GCC, use .c. It takes exactly the same arguments, but now we have a file that has different output for the same input, because we're actually using two files. What .c is doing is you can run .c pre. That's like running Browserify without an output. So here's what it did. It's very simple. It just generated a namespace for foo.c to live in right here. And then when we refer to foo in our code, it just puts that namespace there. That's it. It's very simple. But the crazy part is you can install modules with npm. So there's this module called log timestamp.c that somebody already published. I just blogged about this a few weeks ago. And somebody already published, a number of people have published packages. It's great. It's that crazy distributed collaboration model I was just talking about. So if we want to use this package, it's also very simple. We can just require log timestamp.c as log with capital L. Why not? And then instead of printf, we'll just do that. We don't actually need stdio anymore either, so we're removing those includes on the fly. So if we .c main.c, whoa, it worked. So this is crazy, right? Because now we have a timestamp that module provided us. So we didn't have to write that functionality. We didn't have to find it in some Stack Overflow post somewhere. We didn't have to dig it up from our collection. We can just use modules the same way we're used to in Node. And so .c also has a search command. It's .c search, but network, right? So this is just npm search, but all it's doing is it's filtering the search terms by packages that end in .c or .cc or .h. And it's only showing you those. So if you npm search and you see something with .c, it's a C file, just a heads up. People are going to be doing more of that, I hope. I'm certainly advocating it. But this is really great because now we have something for those like scientists that were discussed yesterday. Somewhere for them to put their code, which is great. They don't have to like copy it amongst themselves or put it on flash drives or maybe put it in a paper in PDF form and you have to copy paste it, something weird like that. No. We don't have to do any of that anymore. We can put it on GitHub. We can put it on NPM. Everything can be nice. It'll be great. NPM is pretty much amazing, but maybe we can take it even further, right? So I have this other crazy idea. Isaac is pretty hands-off about it, but maybe eventually we start doing this enough to be like, whoa, and kind of take the reins off of us. So how do we prevent this ahead of time? Well, maybe we can have a lot of NPMs that all talk to each other, and they're distributed, and we can create, we can continue this proliferation, and nobody can stop us. What do we need to make first for this to happen? Well, have this idea maybe. I just stole it from Dominic Tarr, but Anarchy OS. Basically, what NPM is a package manager, and those used to be in the domain of like Linux distributions or whatever. So why don't we just have like basic operating system components? Why don't we put tools there that our systems need, and we could just polyfill it for all of the other platforms? So, for example, I've got a little tool here called WIT that I've been working on. So when you do WIT, it just shims out all these wireless commands. So it's a command line wireless tool. Why don't we have stuff like this? And you can like sudo wit start, and it'll just associate with the network. So here, well, it'll probably connect in a sec, but I can connect to Wi-Fi with these tools. We can just put whatever we want on NPM, and pretty soon nobody can stop us. Nobody will stop you right now, unless you're publishing episodes of King of the Hill, which happened once, to NPM. But there we go. We're online now. But the great thing is you can do whatever you want with NPM. It's this beautiful shared resource, and we really need that kind of beautiful chaos to take hold so that we can just modularize everything. Thank you.